and welcome back to week 3, I guess, of online learning of chemistry. This week you're going to be focused on the study 9.2.1, which is about enthalpy and reactions, and you have the quiz at the end of the week to turn in. So let's get started. Okay, this first part, I'm going to break it apart into 2 sections like I did last week. This first section is more about exothermic and endothermic reactions. The first one, I'm going to show you a little clip of it because it was interesting. These beetles produce this hot, dangerous chemical to defend themselves. They have this chemical reaction that happens inside of them, and it's an exothermic reaction, and it produces this heat, and it's quite crazy. Anyway, Google it sometimes. I was a little scared by it, but I'll show you a little video of it. I know you can't hear, but I'll have the captions on. It's attacking this praying mantis. Of course, y'all missed the graphic music that goes with it and scary music. There's the exothermic reaction, spraying into the praying mantis's face as a adaptation to protect itself. It's a very hot liquid, but I think he still gets it. Oh, no, he's brazen. It's scary. So anyway, I was just interested as to wonder what was going on. So I figured anyway. So what is true about the reaction that produces this defense chemical? It's a reaction that gives off heat. Okay. It's a very exothermic reaction. So we're going to talk about that a little bit as it's coming off. So exothermic, exo, meaning exit. It's giving off the heat. Okay, so it's a reaction that goes through that, we have this. So a very common one we learn about in the types of reaction is combustion. When you're burning something, you're causing this exothermic reaction. It's the heat is giving off that we use to cook our food, to run the car, to heat the home. That's that heat that's coming off of that reaction. So those are all exothermic reactions. Okay. But the opposite we have is endothermic. It's going in. That's kind of how I remember it, even though the spelling's a little different. So the heat is going in. So it's entering the reaction. Okay. And probably the most common of all of them is cooking. You have to put heat, like from the stove, from the oven, into the chemical reaction to form the food. Okay. So that's endothermic. So this is a specific reaction that they use, and it's called, I'm not really exactly sure how to say the name, but it turns, bread into toast, charring the hamburger, giving the pizza the crust. So it's a very useful reaction, and it is endothermic. Okay, you're adding heat in there. Okay, so they're also showing you a different kind of way of looking at this. The red is the hot color. Okay, so the red heat is going out, it's exiting, and the blue is the cold, and this blue, the heat is coming in to it, I believe. So the one that's exothermic is giving off the heat, which is A. Okay. So on this one, we also have different wear, and remember from before, which one's exothermic, which is endothermic? If the heat is giving off, it's often a combustion or a gas or something going on. If it's endothermic, often it's going to be cooking. So I'll give you one right here. So natural gas burning, exothermic. We have steak cooking. So anything that's cooking on this side, anything that's like burning on exothermic. Okay, and you should look at it right. Okay. With this, we can also write heat into a chemical equation. So we have heat being a product over here. That we know is an exothermic reaction because the heat is almost produced or given off and waste. Whereas endothermic, if you need heat to come in, so think of it coming in, that means you need to start with it. It's a reactant on this side. So if we look at these two options, exothermic, remember, the heat is going to be written as a product, okay, because it's given off. Think of these like it's giving off water, it's giving off CO2, it's also giving off heat. So the reaction that's exothermic has it at the end. Heat, when it's at the beginning, this is endothermic. So when the question is asking for exothermic, we're going to pick A. Okay? So with that, we also have phase changes. So we can look at heat being added or taken away, endothermic or exothermic, if we change a phase, such as ice melting, water boiling. So based on what we know kind of about the phases of water, which equation accurately describes what happens when ice melts? Okay, well we know ice is water as a solid. Okay, that's what S means. So H2O, water, is a solid. It's going down to this liquid form. That's what the L means. Okay. Are we adding heat at the beginning to melt that ice? Or is the ice just going down and then giving off heat at the end? Well, think about it. Ice needs heat to melt to water. So that's how I look at it. Ice needs heat to melt to water. And it's going to be an endothermic because whenever heat is written on this left side of the arrow, it's endothermic. So it's going to be A. Okay. So what also happens is that, as I said, the reaction is endothermic. And we're going to start talking about this idea of these heat of fusion, of this change of enthalpy. I'll get more into this next video, which I'll post on Wednesday. But it kind of looks into these graphs as we go forward. So that as you go through these changes, we have this energy change, and we're going to look at it. And does the energy change, like potential energy, is it bigger in the beginning or end or something else going with that? Okay. So the opposite, so if we have melting as endothermic, for the melting of ice, you needed to add heat. Okay. Well, if it's the opposite, if we're freezing to form ice, so we're starting with liquid, okay, we're going to solid. Do we add heat to the water to make the solid? No, you're not going to add heat at the beginning. Remember, the hot solid, it kind of needs heat at the end, like to make the liquid, to reverse the reaction. So it's not going to be endothermic, it's going to be exothermic this time. Okay, so water freezing to form ice, you don't add heat to water, so then we know that one's wrong. So that's got to be the first one, A. Okay. Now I'm going to kind of leave you here a little bit, but this kind of goes into a little bit more of if you've ever like gone next to a freezer, a lot of it's very warm outside of the freezer, and that's because heat is being removed to freeze that food within. Okay, to freeze something, you have to remove that heat. It's got to go somewhere. It can't just magically disappear. And then, so it's just kind of, there's this whole idea that it's kinetic energy, this moving of energy of places, and we can show that into a graph. If you want to go forward and try a little bit more, that's great. I will add in the next half of the screencast for the next time. Well, hope you're having a good day.